Well, hi and welcome to Unit 2, Topic 1, Video 7, Part A. And we're going to look at an example from the bearings topic. Okay, so in this video we're going to use bearings and some contextual examples. The examples will be a little bit trickier and they'll be worded problems, but again we just break them down with diagrams. Be careful of their interpretation, they're not too bad. So here's the first example. Okay, so a plane travels 380 kilometres north and then travels 720 kilometres north 48 degrees east. So we're given that information and we want to find how far away from where it started is the plane. So this is going to be diagram, bit of trig and pretty easy solution, but it all comes out of the interpretation. And the interpretation for bearings problems comes with a good diagram. Now this plane is flying predominantly north. So given that information, I'm going to start my diagram over here. I'm going to start down here. And I'll call the starting point A. North 380 degrees. 380 kilometres. And then northeast. But this time 720 kilometres. And so that's 720 kilometres. And so the resultant distance is this one here. And we'll call that X. Now, it's important to recognise here that we will be able to do this question in a much easier fashion a little bit later in this topic when we do some non-right angled trig. So we will get there, but for now I want to show you that we don't need non-right angled trig for this particular question. We can do it without. So let's do it without. What I'm going to do to solve this question is I'm going to solve this triangle. When I say solve a triangle, it means find all the missing sides and angles typically, but I'm not worried about the angles. Now this is east, and this is north, so therefore that's a right angle. And to solve this triangle, what it's going to do is going to create one big triangle here, and a little bit of Pythagoras theorem, and I'm going to be in. Now, that's going to be my best bet because I don't know this angle, and I don't know this angle. But to solve this triangle, I have to use this information. And the information I know is this angle here is 48 degrees because north 48 degrees east. So I'm now using that bearings to get information. So I'm going to take that triangle out, first of all, over here. I'm going to draw it up and I'm going to solve it. That was bad, but anyway, I fixed it. Fixed it. You didn't even see it happen. 48, 720 kilometres. Right angle, and I want to find how far north I've travelled and how far east I've travelled. So let's do this calculation, shall we? Firstly, north, I know the hypotenuse, this is the adjacent. So I get cos 48 is equal to n over 720, which means that n is equal to 720 cos 48. Now, here's something for you. I can work that out, and I'm going to work it out, and I'm going to round it instantly to 2 decimal places. It's a great opportunity for me to have this conversation with you. So I get this, 481.77, and it's in kilometres. Now this might fail, I've rounded that, might fail, it might not be a huge difference. When I go back to my calculations later on, I'm going to continue to use this in my calculator. There's my answer, and it's a great thing to do in an example to actually evaluate them, but I'm going to use that value because that's called an exact value. I haven't rounded at this stage, I rounded here, so I can save this data. Now you could achieve a very similar result by just writing down all the decimal points in your calculator, but it actually takes a bit longer, and it still involves a bit of rounding at the tail. So by using this value, it's using the exact number, no rounding at all. Now, let's calculate east, and then I'll show you how I'm going to use them. East is opposite hypotenuse, so we're on sine. Sine of 48 is equal to east over 720, so therefore E is equal to 720 times sine of 48. And again, I'll do the calculation, but I'm going to use that exact value. 720 times sine of 48 is equal to 535.06. Oops. I was thinking kilometres. Now, there we go. 0.06 kilometres. That's a 6. So, 481 and 535. So now I'm going to create a new triangle. And it's going to be my bigger triangle. This one here. And this is the distance I want to find. That's my x. I don't know any angles. I know this is the right angle. And I know that this is 380. And this is, and here's me using my exact value, 720 cos 48. Or I might use that 481.77, but that's my rounded value. And over here I've got 720 sine 48, or I might use my 535.06 value. I'm going to do both, but I'll do the work here and I'll make it pretty quick. So let's do the actual one. X is my hypotenuse, so I've got x squared is equal to a squared, which is 380 plus 720 cos 48 squared plus b squared, which is 720 sine 48 squared. And then I'm going to evaluate that quickly, and then I'll take the square root of that. So evaluated, that is 1028948.268 rounded. And if I take the square root of that before deleting off my calculator, I get 14.370873 kilometres. Okay, so this is my good answer. Unrounded values, I use the exact values. Here's my answer if I don't use the exact values. X squared equals 380 plus 481.77 squared plus 535.06 squared, and then I'll get that value. 1028936.737, and when I take the square root of that value, that gives me 1014.36518.9. Now, point not well proven, because to two decimal places that'll be 1014.37, and this will just also round up to 0.37, but we're out by half a kilometre, which actually is a fair distance, particularly if you're making predictions about something. So, no, not half a kilometre, by 50 metres, by 0.005 of a kilometre. So we have to be a little bit careful about our rounding, and you can see that if we had a more significant, or a couple more steps in this question, our rounding here might actually create us a bit of chaos later on. So it's really good to try and keep and use your exact values, which I'm going to assume to do from now on. So this question, given information, and look at that. Nice, it doesn't even have to be a ruler diagram, just a good, neat diagram will give you all the information you need, and the interpretation is pretty easy from there. Okay, so we're going to move on to example 2 now. Give me a moment to rub this stuff off. Well, I hope that example makes sense to you. Remember, you can always watch this video again and maybe have a try at this example specifically in a week or two before watching that video again. All the best.